The introduction. Autodesk Inventor is a 3D CAD software used for mechanical design, documentation, and product simulation. It provides tools for create virtual representation of product, validating their form, fit, and function before they are built. Inventor offers a range of features including parametric, direct, freeform, and rules-based design, as well as tools for mechanic design, sheet metal, and more. So this is a path drawing exploded view. This is the exploded view of the clock assembly. It shows all individual components and how they are arranged to form the complete clock. The view helps visualize the relative position of each part before assembly. As you can see, it includes the back cover, internal page, clock face, hour and minute hand, and the front cover. This layout helps in understanding how each component fit together and support the clock mechanism. This is a clock glass. This is a technical drawing for the front glass part of the wall clock. As you can see, it has a circular shape with 2 key diameter, an outer diameter of 220 mm and an inner diameter 215. The glass has a thickness of 5 mm, making it steady yet light. On the left, there are side views showing the total thickness, including the curved edge. On the top right is an isometric view to help visualize the 3D shape. This is a back clock. This is the back part of the clock, designed to support the internal component. The outer diameter is the same at 220 mm, with an internal diameter of 215 mm. It includes a slot measuring 50 mm by 30 mm to house the clock mechanism. There also a small hole with a 5 mm radius for wiring or tagging purpose. On the left, the side view shows the thickness of each section, especially the 10 mm base and the step layer. The isometric view on the right shows the 3D shape of the part. This is a clock face. This drawing shows the clock face, which is the part where number or marker are usually placed. It is a flat circular disc with a diameter of 220 mm and a thickness of 5 mm. At the center, there is a hole with a diameter of 8.5 mm. This hole is important because it allows the clock hand to be attached to the internal mechanism from the back. This is the technical drawing of the clock number, which are attached to the clock face. The drawing includes top and isometric views. Each number has a diameter of 8.5 mm and thickness of 1.1 mm. The center alignment ensures the numbers are evenly distributed, forming the correct circular layout on the clock face. So this is the technical drawing of the clock body, which serves as the main housing for all internal components. The drawing includes front, side and isometric view. The outer diameter is 250 mm with an inner support ring at 220 mm and a reset diameter of 210 mm. The dip is 50 mm with a 10 mm inset to securely hold the clock face or glass. The isometric view helps us visualize the hollow cylindrical structure from a 3D perspective. This drawing shows the clock ball in top view, side view, and isometric view. This ball for the hour needle, minute needle, and second needle too. The head of the ball is hexagon shape with an outer diameter of 7 mm. Inside the head, there is a circle with a diameter of 5.51 mm. The rounded part of the head has a radius of 4.5 mm. The total length of the ball is 19.5 mm and the shaft diameter is 7 mm. The isometric view shows the full 3D shape of the ball. These dimensions are important to make sure the ball fits and locks properly in the clock assembly. This is the technical drawing of the hour needle, the shorter hand that marks the hour on the clock. The drawing includes top, side and isometric view. The needle has a length of 75 mm, a central hole diameter of 7 mm for fitting onto the clock mechanism, and a thickness of 2 mm. The simple compact design ensures smooth movement and readability.
Minute needle. This is the technical drawing of the minute needle, which is longer than the hour needle to represent minute. It measures 94.94 mm in length, has a 7 mm hole diameter at the center, and maintains a thickness of 2 mm with a width of 8 mm. Like the hour needle, the isometric view helps us understand its proportion and fit within the clock. Second needle drawing. This is the technical drawing of the second hand of the clock. It includes 3 views, front, side and isometric. The total length is 90 mm with a circular hub of 8 mm in diameter. The thickness is 2 mm and the hole diameter is 7 mm, which fits over the shaft. Assembly drawing, 3D rendered view. This is a rendered view showing the fully assembled clock. You can see the wooden case, clock face and the 3 hands in place. This gives a good visual idea of how all components come together. Clock assembly, technical drawing. This is the complete assembly drawing. It showed clock in front, side and isometric views. All parts are correctly aligned and fit. This ensures our design is ready for production or simulation.
Exploded view and part list. So this is technical assembly for the part view and part list for the clockwork. Exploded view and part list. So this is technical assembly for the part view and part list for the clockwork. Exploded view. This slide shows the exploded 3D view of the clock model. It visually breaks down how all the parts are arranged and assembled. This is step-by-step explanation. As you can see, each component is spaced out along the central axis to show the order of assembly. From front to back, number 1 is the glass cover comes first, which protects the internal parts. Number 2, then we have the second hand in red followed by the 10 by the minute and hour hands stacked together. Number 3, behind that is the clock face showing the 12-hour makings. For number 4, next is the clock body frame which hold the face and hands in place. Number 5, and finally at the back is the clock mechanism case. This houses the motor and power source that control the movement of the hand. Why this is important? This expanded view helps us understand how the clock is built layer by layer, making it easier to visualize the design and how each part connects. This slide shows the expanded 3D view of the clock model. It visually breaks down how all the parts are arranged and assembled. This is step-by-step explanation. As you can see, each component is spaced out along the central axis to show the order of assembly. From front to back, number 1 is the glass cover comes first, which protects the internal parts. Number 2, then we have the second hand in red, followed by the 10 by the minute and hour hands stacked together. Number 3, behind that is the clock face showing the 12-hour makings. For number 4, next is the clock body frame which hold the face and hands in place. Number 5, and finally at the back is the clock mechanism case. This houses the motor and power source that control the movement of the hand. Why this is important? This expanded view helps us understand how the clock is built layer by layer, making it easier to visualize the design and how each part connects.
For the conclusion, to sum it all up, we are able to learn how to design a 3D mechanical part using the Autodesk Inventor application. Furthermore, we are able to grasp the basic of computer-aided design and design drawing schematic of a product. We are firmly believe that the skill we have learned will prove how useful it is in the near future where the skills are needed.